Effects of insufficient maternal protein intake on the offspring. The research problem. Protein deficiency is a major contributor to adverse pregnancy outcomes. Sufficient maternal dietary protein consumption is key for a healthy pregnancy, fetal development, and child growth worldwide. To understand the critical role protein plays in development and growth is to overcome adverse neonatal child outcomes within our own communities. The purpose of each study. In Study 1 titled Maternal Dietary Intake During Pregnancy and Its Association to Birth Size in Rural Malawi, we see that the purpose of this study was to find the relationship between maternal dietary intakes during pregnancy and infant birth size. Study 2 titled Protein Intake During Pregnancy and Offspring Body Composition at 6 years. Assess how fetal growth outcomes are improved by maternal protein intake, its long-term effects on the child, including body composition and obesity. Study design. For Study 1, consisted of a cross-sectional study consisting of 203 pregnant women who were 28 and 35 weeks pregnant and had not been bedridden from illness in the last 6 months. Study 2 was a randomized controlled trial. Number of participants included 2,694 Dutch mother-child pairs in Rotterdam, the Netherlands. Study findings. In Study 1, maternal intakes of carbohydrate were negatively associated with neonatal length and abdominal circumference. Intakes of fat were positively associated with neonatal length and abdominal circumference. Vitamin C intakes positively affected birth weight. Frequency of milk intake positively affected birth weight. In Study 2, we see that higher protein intake during pregnancy is related with higher childhood fat-free mass, but cannot be associated with childhood fat mass. The results regarding type of protein used, vegetable versus animal protein, were consistent regardless of where the protein was derived from. Assessment of internal and external validity. In Study 1, we see that internal validity, the confidence is high. Quantified and semi-quantified dietary recall data and socio-demographic variables were gathered. Weight, length, head circumference, and abdominal circumference of infants were taken. 3 repeated quantified 24-hour diet recalls and 7-day reference time frame for analyzing food consumption were done. Results can be generalized to the whole sample. External validity, confidence is low. Maternal dietary intake was done in one session or in one season. Data collected during the food plenty season. Gestational age calculator may be inaccurate and no data on infections. For Study 2, we see that internal validity, it's moderate to high. Energy levels and offspring's fat-free BMI, and fat BMI were measured. Outcomes taken for age and sex for ages 6 and no greater than 4, or no less than 4. The prospective population-based design, large sample size, child postnatal follow-up, and detailed information taken from body composition measurements proved to be thorough strengthening aspects of this study. External validity is moderate. Use of FFQ for protein intake gives slight inaccuracy in measuring BMI and no awareness of exercise as it could possibly skew results. In light of this assessment, I would determine that Study 2 is stronger than Study 1, in large because of the huge sample size and the thoroughness and consistency in the data collection. How this study may benefit from future research. In Study 1, This study can benefit from further research by trying to prove the benefits of a well-designed food-based intervention. This can then create a sustainable strategy to strengthen maternal diet in order to increase proper fetal growth. In Study 2, the study can benefit from future research by further trying to understand why maternal protein intake is specifically associated with higher childhood fat-free mass, but not with childhood fat mass.